Hello guys, today we are going to discuss some of the details of atomic structure, especially we are dealing with Bohr structure. So before we discussing the Neil-Bohr structure, we have to discuss what's Rutherford's proposal. Rutherford proposed that the nucleus is surrounded by a large and diffuse electron cloud, and he also discovered that the nucleus is packed with neutron and protons and overall positively charged. But later he was failed to explain the arrangement of electrons. But in 1913, Neil Bohr suggested that the atoms resembled a miniature planetary system with electrons circulating about the nucleus like our planets circulating about the sun. So here there is a question arises that why does the atom collapse? Here the atom thus doesn't collapse under the influence of electrostatic Coulomb force of the nucleus on the electrons. For the same reason, our solar system doesn't collapse under the influence of gravitational field. So here in both cases there is an orbital motion. The orbital motion, in order to maintain that orbital motion, the attractive force provides the necessary centripetal acceleration. So next we are going to discuss the Neil Bohr's model for hydrogen atom. So consider a hydrogen atom with a single electron circulating about the nucleus that has a single positive charge. The radius of the circular orbit is r and the electron moves with the constant tangential speed v. Then the attractive Coulomb force, we all know what's the equation. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. Over here the charge is E. So 1 by 4 pi epsilon 0 E square by r square, that is equal to mv square by r. Because we have explained that the orbital motion, to maintain the orbital motion, the necessary attractive force is provided by the centripetal acceleration. So that is why the Coulomb force here is equal to mv square by r. So by rearranging or manipulating that equation, we can find the kinetic energy of the electron, that is equal to K is equal to half mv square, that is equal to 1 by 8 pi epsilon 0 E square by r square. And also the potential energy of the electron nuclear system is the Coulomb potential energy, that is U is equal to 1 by 4 pi epsilon 0 q1 q2 by r, that is equal to minus 1 by 4 pi epsilon 0 E square by r. So here we obtain the equations for the kinetic energy and the potential energy. Now we have to find that equation for the total energy, that is E is equal to K plus U, that is equal to 1 by 4 pi epsilon 0 E square by r square plus minus 1 by 4 pi epsilon 0 E square by r, that is equal to minus 1 by 8 pi epsilon 0 E square by r. Simple calculations here. But unfortunately, it didn't work with electromagnetic theory because if you have a charge that revolves around in a circle, then it emits an electromagnetic wave with a frequency equal to the frequency of revolution, and it emits a wave and it loses energy, that loses the orbit's energy gets smaller and the frequency decreases. In other ways, in classical physics requires that an accelerated electric charge such as an orbiting electron must continuously radiate electromagnetic theory. As it radiates this energy, the total energy would decrease and the electron would spiral in towards the nucleus and the atom would collapse. So to overcome this difficulty, this is the major problem. So to overcome this difficulty, Bohr made a bold and a daring hypothesis. So he proposed that there are certain special states of motion called stationary states in which the electron may exist without radiate electromagnetic energy. So we discuss about the energy states or stationary states. Now, in these states, according to Neil Bohr, the angular momentum L of the electron takes the value that are the integral multiples of h. In stationary states, the angular momentum is the integral multiple of h. That is, mvr is equal to nh. The angular momentum of the electron may have the magnitude h, 2h, etc. but never such value as 2.5 or 3.1 h, and this is called the quantization of angular momentum. So we can use this expression for the kinetic energy by substituting the values for V, that is half mv square. We know the kinetic energy expression is half mv square. Substitute for V, that is equal to half m into nh by mr whole square, that is equal to 1 by 8 pi epsilon 0 e square by r. So to find a series of allowed values of radius r, Rn is equal to 4 pi epsilon 0 h square by me square into n square. So the value of a0, that is 4 pi epsilon 0 h square by m e square, is termed as a0 into n square. So the Rn is equal to a0 into n square, where the Bohr radius a0 is defined as 0.0529 nanometer. The expression for the energy becomes En is equal to minus me raised to 4 by 32 pi square epsilon 0 square h square into 1 by n square, that is equal to, by substituting all the values, that is equal to minus 13.60 by n square electron volt. From the previous equation, the energy levels can be calculated. Here, the electron's energy is quantized. That means only certain energy values are possible. So, in its lowest level, with n is equal to 1, the electron has energy E1 is equal to minus 13.60 electron volt, with radius R1 is equal to 0.0529 nanometer, and that state is called as, termed as ground state. The higher states, example n is equal to 2 or n is equal to 3, that are called as excited states. So the ground state n is equal to 1 is termed as the ground state, or the n is equal to 2 or n is equal to 3 is termed as the excited states. And the magnitude of an electron's energy, En, is sometimes called as its binding energy. So the excitation energy of an excited state, N, is the energy above the ground state. So En minus E1, thus the first excited state. So the first excited state, that is N is equal to 2, as excitation energy, that is equal to delta E, is equal to E2 minus E1, that is minus 3.40 eV minus of minus 13.60 eV, that is equal to 10.20 eV. So this is the equation for the first excitation state, first excited state. So the equation for second excited state, delta E is equal to E3 minus E1, that is equal to 12.09 electron volt. So next, the binding energy can also be regarded as the energy that is released when the atom is assembled from an electron and a nucleus that are initially separated by a large distance. So that is shown in the figure, the binding energy and the excitation energy. So next we are going to discuss the hydrogen wavelength in the Bohr model. We previously know the emission and absorption spectrum of atomic hydrogen. But here, without understanding the origin of these spectra, Bohr model is incomplete. Bohr postulated that even though the electron doesn't radiate in any particular stationary state, it can emit radiation when it moves from a lower level. The electron has less energy in the lower level compared to the original level. This energy difference appears as a quantum of radiation whose energy is hf, equal to the energy difference between the levels. So that is, if the electron jumps from n is equal to n1 to n is equal to n2, a photon appears with an energy hf, that is equal to en1 minus en2, that is f is equal to, substituting the values, m e raised to 4 by 64 pi cube epsilon 0 square h cube into 1 by n2 square minus 1 by n1 square. So the wavelength of emitted radiation lambda equal to, you know the equation for the lambda is equal to c by f. By substituting the value, we get 1 by r infinity into n1 square into n2 square by n1 square minus n2 square, where r infinity is called as, or r is termed as, Rydberg constant, that is equal to me raised to 4 by 64 pi cube epsilon 0 square h cube into c So the value of Rydberg constant is equal to 1.097373 into 10 raised to 7 meter inverse. Now we have to discuss about the Ritz combination principle. The Before we going to discuss this, what is Ritz combination principle means? So according to Ritz combination principle, the certain frequencies in emission spectrum can be summed to give other frequencies. So here the Bohr model also account for the Ritz combination principle. Now let us consider transition state, that is N3 to N2, that is followed by a transition from N2 to N1. So F N3 to N2 is equal to C into R infinity into 1 by N cube square minus 1 by N2 square. And next F N2 to F N1, that is C R infinity is equal to 1 by N2 square minus 1 by N1 square. Thus by summing up the frequencies, that is F N3 to N2 plus F N2 to N1 gives, that is equal to C R infinity into 1 by N3 square minus 1 by N1 square. So that which is equal to the frequency of the single photon emitted in a direct transition N3 to N1. So Fn3 to N2 plus Fn2 to N1 is equal to Fn3 to N1. So it is clear from the equation that in certain frequencies in emission spectrum can be summed to give other frequencies. That is described in the last sentence here. The transition from Fn3 to Fn1 is equal to Fn3 to N2 plus Fn2 to N1. So that is clear. Thus, the Bohr model is entirely consistent with the Ritz combination principle. The frequency of an emitted electron is related to its energy by E is equal to HF. So, summing up of the energies is equivalent to the summing up of their frequencies. So, Bohr model also helps to understand why an atom doesn't absorb or emit radiation at all wavelength. Now, we are going to discuss the Bohr theory for the atoms with Z greater than 1. That means we will discuss the Bohr theory for hydrogen atom with a single electron, even if nuclear charge Z is greater than 1. So, for a nuclear charge Ze, Coulomb force acting on it becomes 1 by 4 pi epsilon 0, Q1 Q2 by R square. Substituting the values 1 by 4 pi epsilon 0, Ze square by R square. So previously we had E square. Now we have ZE square. So making the same substitution or repeating the same method, we can find the allowed radii. That is Rn is equal to 4 pi epsilon 0 h square by ZE square m into n square. So that is equal to a square into n square by Z. So now the energies become En is equal to minus m into Zd square whole square divided by 32 pi square epsilon 0 h square into 1 by n square, that is equal to, by substituting the values, minus 13.60 electron volt into Z square by n square. So here the orbits in the higher Z atoms are closer to the nucleus and have larger energies. That is, the electron is more tightly bound to the nucleus. So this is all about the Bohr's theory. Hope you understood and enjoyed well. Thank you.